All right, let's do this. So this is day 2 of 6.5, which is solving radical equations. Similar to what we did yesterday, today is going to take a little bit of a step up in difficulty, though. Our EQ is still how do I solve equations containing radicals or rational exponents. Again, rational exponent just meaning it's a fraction. As a quick little warm-up, go ahead and solve this radical equation. We're going to go ahead and get rid of the 6 outside of that right away. That gives me 2x plus 1 to the 3/5 power is equal to 8. I know then that I'm ready to get rid of the exponent by using the reciprocal power of 5/3. I'm going to do the same thing over to 8. I'm going to raise 8 to the 5/3 power. I'm going to cancel out the reciprocal exponents because those will just multiply to be 1. Then I have 2x plus 1 remaining equals 32, which is 8 to the 5/3 power. And this is what we discussed in the previous lesson, that if you were raising 8 to a power that had an even number on the bottom, such as 2 or 4 or 6, you would need to then do plus and minus. But since our exponent that we are raising both sides of the equation to is 5/3, the denominator is 3. That means then I don't need, this is only going to have one solution. I don't need to use the plus and minus. So here I'm going to just solve this real quick. Take away 1 from both sides. 2x is equal to 31. And then finally divide by 2, and I get x is equal to 31 over 2, or 15.5. So that's what was covered in section 6.5.1, was solving with radicals or with fraction exponents. Today we're going to get into a little bit heavier stuff. Don't worry about that. That was homework. Okay, so we are going to kind of bring back some of try one stuff today into this lesson. So one shortcut that you can use, and you don't need to use it or remember it, but it can be helpful. If you're trying to square something and within the parentheses there are 2 terms, that's what we call a binomial. Binomial just, again, meaning 2 terms. You could always FOIL this out. So, for instance, if I asked you to take square root of x plus 4 and square that, you could just write it as 2 of the same sets of parentheses and then distribute, and that's totally fine. One shortcut that is kind of nice is that if you are trying to square, let's call it a plus b, so some term plus another term. Okay, in this case, we would have square root of x would be what we call a, and the positive 4 is what we would call b. Okay. One shortcut you can use to square this and get the correct answer right away, even after combining like terms, is to just first take a and square it. So if I take this first term and square that, that would just be x. If I take the square root of x and square it, that's going to give me just x. Here's this middle term. Looks tricky, but plus 2ab just means you're going to take a times b and then double it or multiply it by 2. So if I do that here, if I multiply a with b, whoopsies. If I multiply square root of x times 4, those would multiply to 4 times root x. But then I need to double it. I need to times it by 2. So my next term here is going to be 8 square root of x. And then finally, I'm going to take b squared, so 4 squared, and that gives me plus 16. Okay. Again, might seem kind of silly to the formula is kind of lengthy and not something I expect you would remember or memorize, but it can be helpful if you're trying to square something very quickly. And we see that if it's a subtraction, it's almost the exact same thing. The only difference is in the middle we have a minus sign instead of a plus sign. So here, what I'm calling a would be represented by 2x, and what I'm calling b is represented by the number 5. So if I do a squared, meaning I'm going to take that 2x and square it, 2x times by itself would give me 4x to the second power. The next step is I'm going to multiply those two together and double it. 2x times 5 would be 10x. If I then double that, it would be minus 20x. And then finally, the last thing I need to do is b to the second power. Well, that's 5 squared, and that's 25. Okay. So this would be, again, if you foil, if you distribute, if you like to use that Punnett square looking box method, you can do that. But this is just a shortcut to try and square it. I want you to give it a shot, but if at the end of this little section you don't like it, then feel free to you can always foil, you can always distribute, that'll always work. So go ahead and give this a shot if you want. I'm going to go ahead and take A, right? 12 is what we're calling A. And then 2x is what we're going to call B. So A squared is 12 squared, so it's 144. The next thing is I'm going to multiply them together and double it. So 12 times 2x would be 24x. I'm going to double that, and it's going to become 48x. And then finally, I'm going to square b, or square my second term. So 2x times itself would be 4x to the second power. Right now, we're not doing anything with this. You'll see how this ties back in a little bit. But that's what I would get if I were to FOIL 12 plus 2x times itself. Same thing here. If I do, this is what I'm considering A, and this is what I'm considering B. Again, that minus sign in the middle just means that we're going to have a minus sign in the middle of our answer. We don't really have to worry about it too much right now. A squared is 5 squared, so it's 25. A times B, so if I multiply those together, that would be, this would be 5 root x. If I then double that, it gives me 10 square root of x. And then finally, I have to square b, which would just give me x, because when I square the square root, they cancel out. So there's our finalized trinomial, or 3 terms that we get from multiplying. Again, if you don't like it, don't stress about this, but it will be helpful to kind of condense some pretty lengthy problems that we're going to do in a little bit here. All right. So yesterday we did problems that looked just like this. The difference is we didn't have our variable x on both the left side and the right side. You've learned in the past, if you have x if you have multiple different types of x's in the same problem, like x squared and x to the first, to get them all on the same side. But with this, with a radical, if it has a square root equation, I'm still going to treat it like I want to get the square root. I want to get this all by itself, because then I can just square both sides of the equation. So here I'm going to go ahead and add 5 to both sides. Okay, and that's going to give me the square root of x plus 7. Oops. The square root of x plus 7 is equal to x plus 5. I, of course, can't combine those together because one is a variable and one is a known number. So there's our first step. Now I'm ready to square both sides. Okay. And here's where students will mess up quite a bit, actually. We know that when I square and square root, those undo each other, and I just get x plus 7. But the right side is what students get thrown off by. They think that since I have 2 terms, x and 5, that I can just square each one individually and write it as x to the second plus 25. This is incorrect. This is not what this is. Because as we know, to square something means you have to take the value and multiply by the same thing twice, or the same thing. So this is where, if you want to use the trick, the squaring trick that we just used, do that. If you don't want to use the squaring trick and you want to just multiply x plus 5 times x plus 5, go ahead and do that. Okay. No matter how you do it, afterwards we should end up with x squared plus 10x plus 25. Okay, so that's the squared version of our right side, and then we just have x plus 7. Now this is where we're going to bring back last trimester with a force. And hopefully we remember factoring. And if you don't remember factoring, this is something that we will practice a lot. And if you're struggling, check in with me and we can get you some extra practice with that. Here, to solve this equation now, okay, I've got x on both sides, but there's no radicals. So this is where I'm going to move all the terms. I'm going to move everything over to the right-hand side so that I get 0 on one side of the equation. Okay, I'm going to choose to get the left side equal to 0 because there's only 2 terms, whereas on the right side there's 3. So I'm going to go ahead and subtract x from both sides. Notice that I'm subtracting x from the 10x because they're both the same power. And then I'm going to minus 7 from both sides here. Again, subtracting 7 from the 25 because they are like terms. Then I'm going to go ahead and just look to simplify this thing. Okay, that's going to give me x to the second plus 9x, because remember this is 10x minus 1x. So 10 minus 1 is 9. And then 25 minus 7 is 18. Okay. So I've squared both sides, I've moved everything over, and now I need to try and solve this equation. This is where last trimester you either factored or you did the quadratic formula. Most of these problems you'll be able to solve with factoring, just because having to do the quadratic formula on top of all this would be kind of a pain. The way I set this up, and every teacher does this differently, I know that I'm going to factor it to look like this. I know that in order to make this x squared, I need to do x multiplied by x. And then what I do is I want 2 numbers that multiply to c, or the final number in this case is 18. So I want 2 numbers that multiply to 18 that add up to my b value, or the middle number with x. In this case, it's 9. What 2 numbers multiply to 18 and add to 9? That is 6 and 3. And again, don't get discouraged at this point if you know you've had some time off of math and you're like, oh, I don't remember this at all. We'll get back into the swing of things real quick. So that means that in these binomials, or in these sets of parentheses, one's going to be x plus 6 and one's going to be x plus 3, which sounds awesome, but I still haven't actually solved this equation. Now that I factored it, you learned something called the zero product property, which says if you're going to multiply this, some quantity, times another quantity, and the answer is going to equal 0, either yellow or orange has to equal 0. There's no way for 2 numbers to multiply to 0 unless one of them is 0. And so this is where we ask ourselves, okay, what value of x, what number could I replace this with to make 0 in the yellow, in that first set of parentheses? Well, 0 doesn't work. That's a lot of students' first thought is, oh, if I put in 0, it's 0. But we see here, if I put in 0, right, if I put 0 plus 6, that is most definitely not 0. The number that does result in 0 is -6. If I plug in -6 and then add 6, I get what I'm looking for. Same thing here. What number plus 3 would give me 0? And that's going to be -3. So after all that work, and it doesn't look like that much, but it takes a little while. Okay. After all that work, we come up with our 2 answers, which are -3 and +3. Or sorry, oh my gosh, -6 and -3. Sorry. Okay. Now, that's all fine and dandy. You should pat yourself on the back. You made it to the end of a problem. The downside of this section, and this is why we don't have too many 2-day sections, but this one requires 2 days, is because what happens is you have what are called extraneous solutions. In a nutshell, if you square both sides of an equation, you open yourself up to numbers that seem to be answers, but if you go back to the original problem, it actually doesn't work out as an answer. The reason is, and if you really, really care, you can do some research on it. the basic reason is because you're changing what's called the domain of the function. This is the topic that we'll be covering tomorrow, or in section 6.6. But if you're taking notes and you're like, I don't even know what he's talking about, this is the statement you got to star, underline, whatever. If there are variables on both sides of the equation, when you square it. So when we squared to get rid of this, if you look back here quick, at this point right here, when we squared to get rid of that square root, there was x on both sides of the equation. If that is the case, we have to check our answers. There's no two ways about it. Like, I know a lot of students don't like to check their work. They're just, especially for a problem that's that length, it's like, God, that's a lot of stuff to do. But you have to, because it's not always going to be the case. So this was actually that previous problem. If you go back, this is what we started with. So we found solutions of -6 and -3. So all we're going to do, we're going to plug them each in, check to make sure that I get the same thing on both sides. Okay. So if I plug in -6 for both these x's, I end up with the square root of -6 plus 7 minus 5. And does that indeed give me -6? Well, -6 plus 7 is 1. So the square root of 1 minus 5. Well, the square root of 1, again, since we're evaluating, since we're just plugging a number into the square root, this is not plus or minus. This is just, what is the square root of 1? Okay, this is 1, take away 5. Does that equal -6? Well, we see that 1 take away 5 is -4. So this x equals -6. This is what we would deem an extraneous solution. It's a solution that we introduce to the equation by squaring both sides. It's not always going to be the case where you have one extraneous and one not. It's possible to have both extraneous. That's not too common. But let's double check this -3 just to look and see. If I plug in -3 plus 7 and I take away 5, will my answer equal -3? Well, -3 plus 7 is 4. If I square root 4, again, we're only looking for the principal square root, so just +2 minus 5. And that is indeed -3 equal -3. Yes. So that's good. That means this is our only solution to this problem, is x equals -3. And I know that's a lengthy process. And I'm not asking you to do too many of these, but this is where these types of problems kind of culminate and bring everything together that we've worked on. Okay. So if you need to look over another example, or if we can go through another example in class, if that's something that you're interested in, because it doesn't make a lot of sense. Right now, I'm really just going to give you like one of each type of problem, and then we're going to use that to kind of springboard our conversation. So if an equation contains two different radicals, okay, again, we know that these can't be subtracted, because in order to subtract radicals, they would have to have the same index as well as the radicand, or the expression underneath. That's not the case here. So I'm not super elegant with my words. So what I'm going to say is I want to get the crappier looking radical, the radical that's got more stuff inside. That's what I want to get by itself first. Okay. So if I look at this, it jumps out to me right away that this is the radical that's got more stuff going on. So I'm going to go ahead and add the square root of x to both sides. Okay. And what that's going to allow me to do, cancel that out, and I get the square root of 2x plus 1 is equal to 1 plus the square root of x. Okay. Step 1, move one radical to the other side, because they can't be combined. Now we know to get rid of a square root, I'm going to go ahead and square. We're going to square both sides of this equation. Okay. If I square both sides of that equation, on the left side, it's nice and pretty. Square root cancels the square, and I get 2x plus 1. On the right side, not as much fun. I have 1 plus the square root of x, so I have a binomial. This is where you need to either FOIL this out, okay, or you need to use that squaring trick that we talked about. So I'm going to square the right-hand side, and I should end up with 1 plus 2 square roots of x plus just a straight old x, okay. So it's kind of a jumbled mess. We have a lot of things going on, but the key is that we still have a radical in the problem. There is still the square root of x. So what we need to do is we need to do the process we just did over again, okay? And I'm sure at this point you're kind of groaning. I need to get this radical all by itself, okay? So I'm going to move everything else over to the other side. So I'm going to go ahead and take away the 1, which is nice because those cancel each other out. I'm going to take away the x from the 2x. And that's going to give me x is equal to 2 times the square root of x. Okay. Now, at this point, I could divide by 2 on both sides, but I know that my next step is going to be to square. And if I can avoid fractions, like since these, if I were to write that as a fraction, right, if I were to go ahead and divide by 2 on both sides, I'd have, I can't do anything to simplify that fraction. I have to leave it x over 2. And this algebra is going to be a lot easier if I don't do that. So what I'm going to do, and I'm going to go ahead and square both sides of the equation right now. Okay, so I'm going to go ahead and take the x on the left side, and I'm going to square that. And I'm going to go ahead and square the right side of the equation. Now you notice that I put the 2 in the parentheses there with the square root of x. I'm just squaring everything. So x to the second power, that's just x squared. This is going to become 4x. Okay. I square the 2, it becomes 4. I square the square root, and I just get x. So at this point, again, if I have x squared and regular x, this goes back to our study of quadratics. I need one side of the equation to equal 0. So I'm going to minus 4x to both sides. And I get x squared minus 4x is equal to 0. There's a couple different ways you can solve this. You technically can do the quadratic formula, but if I recognize that these two terms have something in common, right? What do they have in common? Well, they both have the same variable x. So I'm going to write this as x times x minus 4 is equal to 0. I'm basically undistributing one of the x's. And now we have the same situation where it's one quantity is being multiplied by another quantity, and that has to equal 0. So either I need the yellow to be 0 or I need the orange to be 0. In order to make the yellow 0, it is just x. So this will give me a solution of x equals 0. On the right side, what number take away 4 would give me 0? What can I replace x with? Well, that's positive 4. All that, right? Like, this is crazy. And I understand this is about as crazy as a problem as you may have ever seen in a math class, okay? But we're not done. And the reason we're not done is because we had the same variable on both sides. I need to go back and check the work. Now, the check is pretty quick. It's not going to take me too long. I need to check 0 and positive 4 to see if I get, when I plug it into the original equation, do I get 1? So if I check x is equal to 0, that would be the square root of 2 times 0 plus 1 minus the square root of 0. And does that give me 1? Well, this is the square root of 1 minus the square root of 0, which sure enough is equal to 1. So that means that this x equals 0 is a good solution. Okay, so here I can mark something off. X equals 0 is good. I'm going to do the same thing with 4 real quick. I'm going to check positive 4 to see the square root of 2 times 4 plus 1 minus the square root of 4 is equal to 1. This gives me the square root of 9 minus the square root of 4. And sure enough, that is 3 minus 2, which is equal to 1. Okay. So in this case, neither one of these solutions were extraneous. These were both good to go. So those are my 2 solutions to this equation. Okay. Again, I recognize the length of this problem, and I'm not trying to say it's not an easy problem. It takes a while. But if you can kind of keep the systematic approach, get one radical by itself, square both sides, and then in this case we had to do that process again. It hopefully won't be the worst thing that you've done ever, but maybe it does. Okay, so we're gonna look at one more type of question, okay? And I know I've thrown a lot of different things at you today, and they've all had a ton of work. But now what the heck is going on, because they have different indexes? One of them is a square root, and one of them is a fourth root. No fear, I'm going to do the same sort of thing. I'm going to go ahead and move this fourth root, because it was negative, and I'd rather not deal with the negative. I'm going to add the fourth root to both sides. Now, you'll notice that this problem is actually going to be a lot simpler. This problem is not going to be as crazy because the right side of the equation was already equal to 0. So when I add the fourth root to both sides, I'm just going to end up with x minus 2 equals the fourth root of 28 minus 2x. Okay. At this point, I could square both sides of the equation. If I do that, if I squared this side, that'd be awesome, because then I'd get rid of the square root. The problem is if I square the right side, that doesn't completely cancel out the fourth root. So that's not the play that I want to make here. What I'm going to do instead is I'm going to look at whatever the biggest index is. In this case, the largest index in the problem is 4. So I'm going to go ahead and raise both sides of this to the 4th power. Okay. And what that allows me to do is that cancels this fourth root, and I just get 28 minus 2x, which is sweet. But on the left side, I have the square root of x minus 2 to the 4th power. But remember, a square root is an index of 2. So really, and the index can be written as the denominator of a power. So if I wanted, I could rewrite this as x minus 2 to the 4 over 2. Okay. And of course, 4 over 2, or 4 divided by 2, is just 2. So now I can rewrite this as x minus 2 squared equals 28 minus 2x. Okay. Now again, FOIL, distribute, box method, whatever you want to do to square the left side. That's going to end up being x squared minus 4x plus 4 is equal to 28 minus 2x. I'm going to go ahead and then get the right side equal to 0, since there's only 2 terms over here. So I'm going to add 2x, subtract 28 to both sides, leaving me with x squared. Negative 4 and positive 2 make negative 2x. 4 take away 28 is minus 24. And so now, again, I do have to factor. I need to find numbers that multiply to negative 24, but add up to negative 2. Okay. And that's going to be, negative 6 and positive 4. So that means the factored version of this will be x minus 6 times x plus 4 equals 0. Okay. X is equal to positive 6 and x is equal to negative 4. These are my 2 solutions that are eligible to be solutions, but still have to be checked to see if they're extraneous. Okay. So positive 6 and negative 4 is what I need to check. Oh boy, didn't leave myself a whole lot of space. what was it? Positive 6 and negative 4. So the square root of x minus 2 minus the fourth root of 28 minus 2x, and that is equal to 0. Okay, so I'm going to check positive 6 first. So I'm going to kind of jump around here a little bit just to keep it shorter. If I plug 6 into the square root, 6 minus 2 is 4. And then if I plug this in here, the fourth root of 28 minus what would be 12, because it's 2 times 6. 28 minus 12 is 16. I'm checking to see, does that equal 0? The square root of 4 is 2. So is the fourth root of 16, and we get 0. Huzzah! So x equals 6 is a good answer. I'm going to go ahead and then check negative 4 as well. So if I plug in, what was it, negative 4? Yeah. So you'll see that this is actually going to fall apart really quickly because the square root of negative 4 minus 2 is the square root of negative 6. And in this chapter, we're not going to deal with imaginary numbers at all. So if I come across something like this, where I have the square root of a negative number, I'm not even going to mess with this. We're just going to cross that out, and that solution is going to be extraneous. If you were to keep going and plug it in, I don't know if you could like make an argument that it is a solution using imaginary numbers or not. I haven't gone through it that far. For what we're doing, we're going to stop. If you see that you are trying to square root a negative number, this is not a real number, so that solution we're going to just deem as extraneous. So the only answer here would be positive 6. Extraneous. Okay. So, again, just some crazy equations, and they're kind of all over the place, and the checking of the work is just another layer to add to it. But if we can just stick with it and make sure we're utilizing each other and asking for help, we should be okay. Your homework is only, 7 questions? Only 7 questions long. It should go, I'm not going to say quickly, but hopefully it's enough practice to kind of get the feel for when to do what with these problems. And stick with it. Like I said, you're taking a high level math class. We're getting into some pretty intense math. So just understand it's going to require some work. So until next time, we will see each other again.